Metal at home, that was the promise 1 year ago at RMRF 2025. This is super high quality stuff.
And my idea was to make metal 3D printing more accessible.
And I was with Matt. Hey, Matt.
Good to see you, Joel.
You did it.
We did it.
You frickin' did it.
Thanks, Joel. It's been a lot of work.
It's been an amazing amount of work,
Yeah.
obviously, because Metal at Home has a lot of really special, unique problems that you have to solve.
Exactly.
And we can talk about those. But first, like, what did you do in the last year since we've been here?
Last year, we've been just really grinding hard in the shop, just really putting these machines through their paces and actually getting metal parts coming off the machines consistently and parts that are good quality. So that's like the important thing is that, you know, this machine produces parts that are as good as industry leading machines on the market. And so, yeah, we've been working hard. We hit that milestone in December. Now we've just been basically putting it through its paces, just trying to get this thing to be reliably printing just consistently. Machines are going out to alpha tester soon. We're really excited, but man, it's been a lot of work and it's showing though. The machine's here.
It's been a lot of work, but you still have a lot of work ahead of you.
We sure do.
Obviously.
Yep.
Let's refresh the audience because obviously there's a physical machine here and not just prints that we're talking about. So when we talk about metal at home, what metals are we talking about?
Yeah, so our go-to is really stainless steel. That's what we print with almost immediately. 316 stainless steel is super easy to print with. It's versatile and it has lots of different applications. M300 tool steel is also a really cool one because you can make like real, you know, fixtures and tool and die things like that, which is really awesome. You can also heat treat it. But then we have Inconel alloys for like more like specialty use cases in aerospace or other high temperature applications.
Or transformers. We made a transformer out of Inconel.
Heck yeah.
Yeah,
why not, man? Transformers are awesome.
Yeah, they are.
Let's roll.
So yeah, you can do all kinds of different alloys, brass, even some coppers and things like that.
Okay.
So we're really just kind of getting into all of the laser powder bed fusion materials, except for aluminum and titanium because of the reactivity.
Yeah.
But it's not precluded from the future. It's just not in this machine today. So.
Yeah. Well, that's still quite an assortment of metals that someone would be able to print with this.
Yep.
And then what is the print volume for the metal?
Yeah, the print volume is really industry leading for this size of machine. We've got 100 millimeters cubed. So this is 4 inches in each direction. And it's basically in the most compact, you know, desktop factory you could imagine.
So let's talk about the look of this machine right now because like it looks awesome. Like
that means a lot.
These are printed parts.
They are printed parts. Yep.
They look really nice.
Thank you.
Some people think that printed parts on a machine speak to not being as built well.
No, it's really just a stigma that really comes from an area of, you know, machines not being reliable in the past, right? And you've probably seen it as much as I have over the years. FDM 3D printers have tremendously advanced since, you know, I've gotten into the industry and you've been in here. And so today we get reliable machines that produce quality parts that are great for production. And so, you know, we're not using 3D printing because it's cheaper or, you know, anything like that. We're actually using it because it allows us to make a machine that's better. There are a lot of engineering systems in here that are actually enabled because we 3D printed the design.
Really?
Yeah. Quite literally. Just the ability to have a machine that's built out of plastic in the first place requires a tremendous amount of thermal engineering, right? I mean, you have a plastic printer that makes metal. It usually goes the other way around, right?
Yeah, it does.
That's a good point.
So we have cooling loops and all kinds of heat exchangers and things inside of here that we have designed and embedded in a self-supporting way inside of this printer that actually enables it to print metal and do it in a compact factor that gets rid of the heat and it manages its own thermal stresses.
I mean, we got fans going.
Got the fans going, keeping it cool.
Lots of fans, keeping it cool.
Yeah, we've got compact blower systems that are actually recirculating the air inside of the machine, and it's all done just because FDM 3D printing. Otherwise, it's stainless steel valves and, you know, fittings and gaskets and clamps. It's a nightmare. It's
metal where it needs to be and plastic where it's...
Exactly. We've been very strategic about where we use our materials.
That's how you do it. This speaks to the speed at which you were able to do because I can't imagine someone attempting to disrupt metal at home.
Yeah.
If they're having to produce molds or cut steel to make parts, like that year would not have been enough to do it.
No.
Like part of the reason that you can go so fast, I think, is because of additive manufacturing.
You are 100% correct. I mean, our iteration cycles are measured in hours and days, never weeks.
That quick?
I mean, this is a new era of engineering and design.
Well, okay, I'm glad you brought that up because this new era, being a desktop version, this is something that could sit on an engineer's desk, or at least not have to be in a medical clean room, right?
Not far off. Yeah, you definitely don't want to get powder in your keyboard, of course.
Sure.
But at the same time, you could have it in your shop right next to where your office is, and you could actually just like run down in like 30 seconds to where your printer is, rather than like, oh, it's on the other side of the building in like Unit C or something like that.
Okay. It's more like a workshop mounted metal printing machine.
Exactly. You wouldn't want a CNC mill running right next to your computer. It's going to be a little disruptive. Sure, there are versions that do, but personal choice, I guess, right?
Yeah. Okay, so I do want to talk about price, but before we do that, like, can I get some models off here, because
absolutely,
these are
that's what they're here for.
These are beautiful, and these are printed on this machine.
A Scrap One machine, yes.
So this little ducky, what kind of metal is this?
This is 316 stainless steel.
This is 316 stainless.
Yep.
Okay.
Yep.
And how long did this take to print?
That was under an hour, I believe.
And then what post-processing was done?
Post-processing, this, I believe, was just wire brush. So just a
that's
little
it?
bit of, hitting it on the wire brush, and that's just to get like a little bit of the loose powder particles off of it. But for example, this part, no post-processing other than sanding the bottom.
Wait a minute. The sidewalls are
That's
natural.
as printed.
And that's obviously what's on the build plate there, right?
Yep, so that was the support material where we cut it, and then we just hit it on the belt sander to kind of like take off the extra support material.
Oh, so you could, if you wanted something to shine, a sidewall to shine like that, you just go on the belt sander and you're good.
Exactly. Yep. Yeah, it polishes up really nicely.
If someone were to have a Scrap One machine and were to print these in stainless 316, what's the anticipated cost that you're kind of eyeballing?
Yeah, it really depends on if you factor in your time or not. It really does.
Do we really? Do any of us really?
If we're not, I mean, we're talking about like single-digit dollars for those parts.
Really?
Yeah, like this is not, like the materials are pretty inexpensive. There's not a whole lot of material here. And on top of that, you just really don't have that many consumables. We have like a HEPA filter that every few hundred hours we just need to replace. And then some like really low cost consumables like the recoder blade, which is just made out of silicone tubes. So it's really inexpensive stuff. And the build plates, you get dozens of cycles out of them before you need to replace them. And they're maybe $30, $40.
Wow.
Yeah, so
we're really looking at like a metal future here.
Yeah, this is something where this is actually a competitive process for like any type of even like plastic printing versus, machining. Once you start getting into this realm where the machine cost isn't your big inhibiting factor, then all of a sudden you start to unlock this is a competitive process, because even if it's not quite as fast as, for example, machining, if you wanted a bunch of these parts, well, you could just buy 10 of these printers, and that can actually become competitive. And so there's all kinds of different areas that this unlocks now as a competitive process.
What is the price point of the Scrap One that you've got?
Yeah, so we started out with an early bird special that gets us a $9,600 kit. And so that kind of gets the makers and the enthusiasts in the door that just want to kind of like a project, something to tinker on. And then if you want something that's turnkey, kind of a production solution, plug and play printer right now is $12,900.
Okay.
And once the early bird special ends at the end of April, it'll go up $5,000. It sounds like a lot, but to somebody who has looked into metal 3D printers even just a little bit, it's usually a wow, a jaw-dropping moment. Oh my God, where do I sign up?
Shut up and take my money.
Let's say the people that don't know about the price of this, if you were to tell them something to try to get them to relate to what this would cost and why this is a good price, what would be the thing that someone would get if they wanted something like this, but right now? That wasn't this.
Oh, well, the price would be order of magnitude higher.
Okay.
So yeah, my last company, Exact Metal, sells machines $100,000.
They do, yeah.
Approximately. And that was a big deal when we offered the, first printer in 2017. And that was, really an order of magnitude above or below from the competition then.
But those are still big machines, right?
Very big machines.
Okay.
Those are floor units, pallet jacks,
medical clean room,
yep,
bunny suits, the works, right?
Yeah, exactly.
Okay.
And this is something that, like two people can carry and just put on, a bench top somewhere.
Yeah, or I can carry it, I'm strong.
You can carry, you are strong, I saw you move that.
This is what I want to really get across to the audience, because that price is for something that doesn't exist yet in the industry. This is a first, isn't it?
This is really a first. We're introducing a new level where machines that produce this level of quality just aren't in this order of magnitude for price yet. So
okay, well then the last thing, let's talk about 12 months from now, because our first meeting was 12 months ago, And in that 12 months, you went from not having the machine to having working machines, alpha testers, beautiful parts. What does 12 months from now look like?
Yeah, 12 months from now is production. So that's really where we're hoping to be in 12 months, is that we've gone through the alpha testers, we've gone through the beta testers, and they've all given us enough feedback that we've integrated into the machine that we feel confident starting to ship this to everyday users who just want a machine that works. They don't want to tinker with it.
That is, oh man, I can't wait. And I knew this was something special when we saw it last year. And when you reached out and were like, hey, we're gonna have a machine there, like that's when my jaw dropped. I'm like, metal at home. Like, really, that's what we're talking about.
Yeah.
The floor is yours at this point. I'd like you to look at the camera because tell everybody where they can go to find out more about this machine and what you're doing.
Yeah, if you want to find out more about the Scrap One and how to get one, you basically just have to go to our website, scraplabs3d.com. And there we've got all the information, all the specs, and you can put a reservation down if you want to get in line to get one of these as soon as possible. So everything's on the website. If it's not, shoot us a message and we'll reach out and hopefully get you the answers you need. So, yeah.
Matt, thank you, man. I really
so much,
appreciate
Joel.
it. Hey, thanks for watching. If you made it this far, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, come to Remurf next year, and as always, high five. Going?
Let's go.
Oh,
That's a good one.
nailed it.
Yeah.